Just going to create a generic fluid design here. Not using any standards, but this could be set up. We will just go as generic as possible, just to show a method. So because I'm not using a standard, there's no bin standard being applied. So what I'll do is I'll just go ahead and run this, and we'll come back after the fact and say we're going to put in 30 millimeter radius on these corners. Okay. Like I said, this is not using any preset standards. This is just out of the box with no standards. So I think what I'll do now is export a list of nodes, which are these nodes up here. And I'll just name it whatever I want here. Okay, so now we have a set of nodes to use. I'll exit, and then I'll initialize a new product, by the way, or a new pipe. By the way, this will default to 20 millimeters diameter, so I just know that. So I'm going to make the next pipe large enough to go around it and have enough room. I think it'll have enough room for mitered corners. I'll go with a 40 millimeter OD for this second pipe. And to create this pipe, I'm going to go grab that same set of nodes and import. And then change my standard back to 0 here for the bend radius, which will imply the mitered corners. Okay, and then we will exit. Taking a look at that, we'll section it so we can see what's going on. So here you can see the result. Now the other piece of the puzzle that I'm supposing we could do is, instead of just using these as two separate pipes, I think we could take the text file and create a set of explicit points, which means they don't have XYZ values, they're just geometric points, and then constrain them to the nodes on this internal pipe. And by constraining those to those nodes, anytime the internal pipe moves, the external pipe would move as well. That's the part I haven't confirmed yet, but the logic is all in the system. It's just a matter of going through and proving it. So that's just a quick overview of the thoughts I had. So I'll come back with a proof using the import method and locking the imported nodes to the internal pipe.